Okay, so before we start this lesson 8.7, let's do number 39 from lesson 30 or 8.6. Okay, so let's do that real quick. Here's the triangle. Looks like this. And this is 39. So really, 38 and 39 are the same basic problem. They just give you the lengths of the three sides. So 33 is the same way. Yeah, 33 is the same way. They give you the lengths of just the three sides. So I told them I told the other class I would do this. Well, that's a 20, not a 29. And that's a 40, what is it, 8? Okay. First of all, can we use the law of sines to start this out? No, we can't, because in order to use the law of sines, we need to know one angle and one side that's opposite that angle. Right? We don't know an angle here at all, do we? So I can't use the law of sines. So I can use the law of cosines. I can find any of these angles that I wanted. Let's label them C, D, and E. Doesn't matter which one you find. I don't know if one's better than the other. Anybody have a favorite? 48D? Okay, so let's use this one right here. So let's use law of cosines. So we're trying to find angle D, so what do we start with? We start off with side D out front here. So it's going to be 48 squared equals, now the other two sides squared and added up. So it's 52 squared. Man, my throat's killing me. It's a wonder I got through today. 52 squared plus 20 squared minus 2 times these two multiplied together. So that's 52, 20. Times the cosine of the angle. Now we don't know the angle, do we? So we'll call it D. And that's what we're trying to solve for. We're just trying to do some math and solve for angle D. Excuse me. All right, remember the algebra. Basically 3 steps. Let's get rid of what's being added first. So 48 squared is already over here. So we get rid of 52 squared by subtracting. Gets rid of that. Get rid of the 20 squared by subtracting. Gets rid of that. See what I did? I just subtracted it, put it on the other side. Now, this negative 2, 52, and 20 are all being multiplied, so get rid of those by dividing. So really, once you get the hang of this, the algebra is not that bad at all. 52 and 20. Okay, so we got rid of all 3 of those. So all that stuff is equal to the cosine of D. But I want to find what D is equal to, right? So how do I get rid of that cosine? I don't divide by a cosine. That doesn't make any sense. So we take the inverse of the cosine. So look, in one fell swoop, we can put it into a little easy way to throw that into a calculator. So let's do that. So let's hit it. Second function cosine. So there we go. Now remember what I do with this. I put a parentheses right here and one right here. I think that will help you out on the calculator. So we put another parentheses, left parentheses. Now we can put all this stuff in here. 48 squared, excuse me, minus 52 squared, minus 20 squared. If I'm doing something wrong, let me know. All right, we close that parentheses. That's this little parentheses right here. We closed it. And now we divide it by, and I don't know. I like to put that in parentheses too. You might not need to, but I like to. Negative 2 times 52 times 20. Close the bottom. All right. So what I did here is I put a parentheses here and I put a parentheses here. Is that all right? And now what do I want to do? I want to close that parentheses, and I think that's all I got to do, right? As far as my parentheses, and I should hit enter. And there you go, 67.4. Does that sound right? 39. Yep. Now it is an angle, so what do they tell you to round the angle to? To the nearest degree. So we'll round it to what? Just 67 degrees. Okay? So that's angle D. So now we actually know one of our angles. So if you wanted to, you could now use the law of sines to find one of the other angles. Or if you wanted to, you could use the law of cosines again, couldn't you? You could do the exact same thing, but do it with like this angle right here. So if you wanted to do that, that would be fine. Once I get this angle, how do I find this one right here? If I know two of them, that's all my hard math, and it's just easy. Just take those away from 180, and I've got this angle right here. So you could do law of cosines to find this, or you could do law of sines. Just to switch it up a little bit, you want to do law of sines on this? Sometimes, though, I said we weren't going to get into it. Remember I talked about the ambiguous case? Sometimes that shows up when you use law of sines. Hopefully it doesn't happen here. We'll see. Don't worry about that. You'll worry about that more when you, hopefully you won't worry about it, but you'll learn more about it when you get into Algebra 2, this ambiguous case thing. But let's use a law of sines and see what we get. So now I know an angle and a side opposite. What do you want to find? Let's find C, since we're finding that, okay? So let's set it up like this. 48 over the sine of 67. Remember, this angle has to be opposite this side, so I have to use those. Equals. Now, if I want to use angle C, I have to use this side 20 right here. So I use 20 over the sine of C. All right? Now we can cross multiply. So I get 48 sine of C equals 20 sine of 67. Let's solve for C. Divide both sides by 48. And then we want to solve for C, so we take the inverse sine of it. So C is equal to the inverse sine of all this stuff. I'll just put an arrow there. So go to our calculator. Hopefully this works. Turn it on. Clear it. Okay, so what am I going to do? Hit inverse sine first. Inverse sine of, I'm going to put the top stuff in parentheses. Yep. So it's 20 sine of 67. Close that parentheses and close the top. Is that right? I think I might have put one extra parentheses in there, didn't I? I think, do we close that one more time? I don't think we do, because we need this, because we still need to divide, right? Yeah, divided by 48. Now we'll close that one and we'll close it again. That should be good like that, right? Because you got 2 here, you got 2 here. Hopefully that'll work. 22.6. Is that about right? Yep. What does that round to? 23. All right, so C equals 23 degrees. All right, good. So I got a 67. I got a 23. That's all the hard work, isn't it? Now all I got to do is just take that away from 180, and I get that, whatever that is. So what is it? 180 minus 67 minus 23. Oh, it is 90, isn't it? Doesn't look like 90, does it? But that's okay. Doesn't have to look like it. The numbers work out, don't they? There you go. All right. I hope that helps a little bit. I don't know if you even had a question on it, but I figured we'd go over it anyway since we hadn't done one like that before. All right. Why don't you turn that homework in, and then we'll go on to the actual lesson 8.7. All right, section 8.7. I don't know if you've ever talked about this before or not. I told my last class. I guess there's a lot of 9th and 10th graders in there. I said, have you done vectors like in 9th grade science? Who's a 9th grade in here? Did you do vectors? Have you done physics yet in there? Have you been?
Yeah, we're doing physics.
You're doing physics now? Okay. My guess is that you'll probably talk about vectors at some point. When you take the real physics, okay, not just 9th grade, you know, what do you call it? Not life science. What is it? Like
Physical science.
Physical science, right. When you take physical science, what do you learn? You learn like chemistry and physics and like earth science and stuff like that, right? That kind of stuff. Well, you'll talk about vectors eventually, especially in physics. You talk about vectors a lot. I mean, almost all of physics deals with vectors. Not all of it, but a lot of it deals with these things being vectors. So it's good to get a good little bit of groundwork before you actually get to that. Of course, some of you guys are in 8th grade. It's going to be a while before you take physics, but when you get to it, hopefully you'll remember a little bit of this thing right here. Well, the main important thing about a vector, there's actually 2 things that's very important about a vector. Excuse me. Oh, man. There's two things is true about a vector. One, a vector has a thing called magnitude. We'll talk a little bit about this in a second. It's got magnitude, and it has direction. Despicable Me?
Yeah, they changed his name from Victor to Vector.
Oh, is that right? Well, there you go. I don't even know what that means. Despicable Me. Is that? Oh, is that what those little green, those green bubble
like
things
yellow with blue on the bottom of
with the little antennas on them or something like that? Or
That movie was stupid.
I just saw the previews on TV, so I know what you're talking about now. So one of the characters' name is Vector.
Yeah, and he's like, Vector is a mathematical term that means something with magnitude and direction.
Look, see, there you go. It's in the movies. How about that? See, it's world famous. Okay, let's get back to this. That is pretty interesting, though. I'd like to see that. Shh. Guys, stay on topic, okay? Thank you. All right, so magnitude and direction. What do you mean by the magnitude? Well, let me give you an example in physics. In physics, you deal with this a lot. You deal with velocity. Velocity basically means how fast you're going, but velocity is actually a vector. Velocity can be broken down into two things, magnitude and direction. The magnitude of velocity means how much of something or how fast you're going. So if you were to ask somebody what their velocity was, or you're trying to find something's velocity, you're finding how fast they're going, but that's not the only thing, in which direction that they're going to. So the magnitude would be like the speed in which you're going. This only deals with velocity, by the way. There's all kinds of other things that are vectors. There's momentum. That's a vector. There's force. That's a vector. There's all kinds of things like that. Acceleration is a vector. Even the thing called displacement, which means how far you go, is a vector. So maybe you'll hear some of those words since you're starting that in your science class now. Okay, so look for some of that stuff. So in velocity, the magnitude of velocity is the speed. I like to say, like, how much of something is the magnitude. How fast, how much force, how much of something, and that's the magnitude, how far. The direction, of course, means the direction, which way do you go? All right, so I don't know if I need to even put anything after this. So direction means, I don't know of any other word to say but direction. What direction are you going? Where are you headed? All right, so that is your direction. So look at this one. When you talk about the magnitude, especially in math and in physics, the length of the line is very important. So watch, the length of this line right here, the length of the line would represent the magnitude of that vector. And of course, let's do a different color for this. Most of the time, not all the time, but most of the time, when you find the direction, you're taking it from one specific place, and that would be from the positive x-axis. Okay, going counterclockwise. We're not going to get real heavy into this. In Algebra 2, you'll see a ton of this, in pre-calc, of course, and that kind of stuff. But in physics, this will be very important to you. So if you start from the positive x-axis, going in the counterclockwise direction, see what I did? Going counterclockwise is the opposite that the clock goes, right? Clock doesn't go this way, does it? Clock goes this way. So this is counterclockwise from the positive x direction. We'll call that theta. That would be my direction. So you need to find out two things: how long that line is, or that from the beginning to the end, and in what direction is it going. Let's talk about a couple points here. This point, this is your starting point. Okay, we call that our initial. They use that word a lot in physics. They call that your initial point or your initial velocity. And this right here, at the end of this, we don't call it the end, they call it the terminal. Okay, terminal means where you end. You ever hear about like the subway terminal or the train terminal or the plane terminal? Okay, terminal means that's where it ends. That's the end of the flight for the plane when it pulls into the terminal, okay? So that's terminal, the ending. So initial and terminal points. Make sense? Pretty simple stuff. So that's just kind of basic vocabulary for this stuff that we're going to do. And we're going to do a lot of things. We're actually only going to cover half of this lesson today, just because the other class, that's where they got. And I think it might be a good spot to stop and just kind of chew on it a little bit and think a little bit about what we've been doing. I will do one thing, though. what they're going to do is they're going to ask you to write this. They're going to write a vector in component form. Write in component form. Basically, it means to break down your vector into its parts. All right? So let me just show you real quickly. I didn't do this in the other class. I should have thought about this. Let's say I had a vector going like this. We'll make it pretty easy. Okay? And if I was going to break this down into its parts, watch what I would do. In order to get from this point to this point, pretend you were like in the middle of New York City. You can't, normally you don't go diagonal in New York City, do you? Usually you go up and over, right? Or over and up, because they're all city blocks and that kind of thing, for the most part. All right? So if I was to get from this initial point to the terminal point, what would you do? You would go over, and then you would go what? You would go up. Whoops, missed it. Let's just say there. I should have. Let's try this again. There we go. All right. I didn't quite go to the. Okay, so if I broke it down into its components, this is kind of like your x component, and this is your, what do you think? Your y component. This is your actual vector right here, but we want to break it down into its components. So at this point, we start with, we'll call it x1, y1. So what do you think we'll call this point where it ends? Good guess. x2, y2. So if I wanted to figure out how to get from here to here, it's basically kind of like the slope formula, isn't it? It's kind of like rise over run, you know, how far do you get here and here, how do you go here? But we don't write it as a fraction like you would the slope. What they do, I guess different books write it different ways. This book writes it like this. I don't even know if they have a name for these, but they kind of put it in parentheses. All right, but it's not a parentheses. It's kind of like an arrow-looking thing, and it's not like a regular bracket. Yep, that's how they write it. Okay, so that's how we're going to write it. And what we're going to do is we're going to put the x distance in the first part. It's kind of like an ordered pair, but instead of a nice parentheses like this, they put it as these little arrow things. Don't know why they came up with that. Probably just to signify to you this is not just an ordered pair. These are the components of a vector. All right, so they needed a different symbol. Matt, you getting all this, right? Because you have no clue what I'm saying by sitting down. Like, sit up, sit up, sit up, and pay attention. Once you get your hand off your head, that might help a little bit too. Sit up nice and straight. Nice and tall, nice and straight. There you go. Okay? So let's take a look at this. How would I find the component vector? How would I find how far I went from here to here? What do you think? This is at x1, and where is it here on the x-axis? That's where? It's at x2. How do I find that distance that I traveled? Right, I went x2 what? Minus x1. Make sense? Okay, what about from here to here? Now this is y2 on the y-axis. What is this right here? That's y1, isn't it? Okay, so how do I find the distance between there? I go y2 minus y1. Make sure you go in that order. Make sure you go from your terminal, from the terminal to the initial. I should say this. The terminal minus the initial. Okay, so where you end up minus where you started. You got it? So it's x2 minus x1 and y2 minus y1. That's how you can break it down into its component. Basically vectors, really. These are also vectors, but into its component parts. Okay? I don't know if you ever heard about, you know, you take a car apart. These are the components, right, to your car. You know, you've got this, you know, you've got your transmission, you got this. I don't know much about cars, but break it down into components, into its parts. So this vector, this purple one, is broken down into those two components, your x and your y, and that's how you would write it. So let's do a quick little example just to show you what they're looking for here. Okay, I've got a little x and y axis here. I'm going to put a couple points in here. The first one is -1, 3, so that would go right there. So that's -1, 3. Then there's another one at what? -3, -1. -3, -1, right there. And if you look how they drew it, what's a good color? I haven't used one. Let's go with this darker purple. They actually start from here, and it does make a difference where you start from. Okay, start from here, and we went to this point right there. How do I know that that is my initial and that's my terminal right there?
Draw an arrow.
Draw an arrow. That's right. No, we don't want to guess. We want to know for sure. So we draw an arrow, so that means that's the beginning and that's the end. You got it? Initial, terminal, beginning, end, whatever you want to use. So what I want to do is I want to break this down into its components. If you look at this, again, I wish I would have done this in the other class, but watch. If I broke it down to its components, this would be the y component, right? And this would be the what? The x component. So how do I find this distance from here to here? Well, I subtract. I don't measure it. I got the numbers already. I don't have to measure it. What do? Just subtract, right? This is at -3, and this is where? At -1 on the y-axis. What about the x? This is at -3, and this is at -1, so you subtract them, okay? So let's go ahead and do that. So what would our components be? We do the x's first. So really, do you even need the picture? No, just look at the, if you know this is your initial and this is your final, or your terminal, then you just subtract in that order. So I go final minus initial, or terminal minus initial. So what would my numbers be here?
-3.
Right? -3 minus -1. Good. And then do the y's. What are the y's? It's final minus initial. So it's -1 minus 3. And then you just simplify it. What's that going to be? Oops. -2. And this is -4. So basically, what did this tell you? This told you along the x-axis you went -2. Do you see that? So along here was -2. Along the y-axis was how far? Was -4. Do you see that? So really, what did you do? It said, what does this thing tell you? This says, what is the y? Like if you wanted to go from here to here, it says you go down 4, 1, 2, 3, 4, and you go what? To the left, not just over, but to the left 2 places, 1, 2, and that gets you to your end point. So this does tell you something about this vector, doesn't it? It tells you how to get from here to here instead of just going straight down this line. What if we were like on a city block, right, or a coordinate plane like this? You could only go up and down and left and right. That means you would go down 4 and you would go to the left 2 to get to there. That's basically what that stuff's showing you. It's kind of weird. We'll be doing stuff with this a little bit later that'll make a little bit more sense on why we draw it like this, okay? We'll stop right there. Tomorrow we're going to actually find out the angles. We're going to do some more about finding the length. Remember what I said? The magnitude and direction? So tomorrow we're actually going to find the magnitude, how long that line is. Because we didn't determine how long that line was yet, have we? What's that?
We should use the
Yes, we could. You definitely use the Pythagorean theorem to find that thing right there. Absolutely right. Or you can use what? Just knowing the 2 points. If the distance formula. But remember, the distance formula is basically just Pythagorean theorem anyway. That's how we got the distance formula. So you're absolutely right. It's Pythagorean theorem or distance formula, right? Okay. But then we got to do some stuff that we've been learning in this chapter to find the direction, because we're finding an angle, aren't we? The angle in a triangle. So that takes a little bit of thought to figure out what that angle is going to be. So we'll talk about that tomorrow, though, okay? And I'm going to be nice to you tonight and not give you homework.
Yes.
But tomorrow I will give you homework.
Because that's easy anyway.
So I'm off a little bit. Listen to me. I'm off a little bit from the lesson plans because I was planning on finishing this and giving you work on it. But still, you can look at the lesson plans. I will make up for it in the week, and it's kind of built into it. So so you'll be fine. So no homework tonight. Enjoy tonight because it's not going to be like this the rest of the week. So okay.
Look at that.